Okay, we continue sensor technology and industrial application.
As we discussed the Internet of Things in the industrial context as IIoT, we talked about how we connect various kinds of devices to embed intelligence in the manufacturing products and processes. In fact, these devices play an important role in collecting information in these manufacturing processes and enabling actionable insights through this real-time information. Now, these insights that we get from these real-time information, right, they come from a technology that is embedded in these devices. It's called the sensor technology. The sensor technology actually enables these devices to collect the information from the manufacturing process or the environment, whatever we are interested. And these technologies play a very important role in enabling industrial Internet of Things as a concept. You may also recall that in the introduction of this series, I talked about the important hexatech trend, the 6 big tech trends, and the emergence of smart sensor network was one of the technologies that I referred to. And it is important for us to understand the sensor technology a little bit more as we build our understanding around the industrial Internet of Things. So let us understand what is a sensor. We can take a black box view of sensor, something that takes an input and then can create one or more outputs. For example, we talked about thermostat. Thermostat takes the input is basically the current temperature of the room. It senses that information, and then it could either display that as one output, or it could send that information back to the cloud. So those are a couple of outputs. Now your smoke detector in your room, another sensor that we always are used to, right? I mean, that's constantly sensing for smoke or something related to that, and then if there is detection, then it just beeps. Okay, so that's another example of a sensor, just a black box taking some input and then giving one or more outputs. More complex sensors, can also take multiple inputs. For example, you could have the same sensor that actually both senses your temperature, and you also maybe senses the moisture of the room, and it could also, sometimes in industrial applications you could have sensors that do multiple sensing, whether it is heat or whether it is movement, whether it is pressure, all this stuff. So when you take multiple inputs and then you can convert that into multiple outputs, of course the sensors become a little bit more complex. That black box inside the sensor now, instead of being just a simple logic, the logic in that could be a little more complex, right? And then that's what is captured in the microprocessor chip, that actually where you program the logic of how that sensor should behave. We come across sensors in everyday life. In fact, you can kind of understand sensors in the concept of a simple, what I would call as a consumer sensors, that we kind of come across these sensors on a day-to-day life. When last time you went to the grocery store, you would find that you're just kind of you're scanning your item that you're buying. There's a sensor there which is actually looking at the barcode often and then reading the information. There could be multiple sensors as you're walking through the aisle in the grocery store. In some grocery stores, they also have smart cards which actually kind of digitally displays information if you actually scan a particular product, you want to know the price or some information about that particular product you want to buy. In some companies, it's kind of quite prevalent now where they use sensors or identification devices in their personal identification cards, and they can use that for gate pass, kind of open doors, where it senses and recognizes the identification of this particular card and then give the required access that is needed. Those are some of the examples I call consumer sensors because directly we use it as consumers, as citizens. And there are also industrial sensors in the context of manufacturing, like on the left hand side of this slide. We could have simple robot. The simple robot which actually kind of takes some input. They sense the movement of some other part. They sometimes sense the movement of a conveyor belt, and they take an action. Right? There are multiple sensors inside the robot. The more complex the robots, you'll see computer vision. They call the eyes of the robot. They are sensors in some sense. And we also have complex, the PLC machines we talked a little bit earlier in the introduction. These PLC, the programmable logical controllers, they are actually, in other words, they're also big sensors, right? I mean, complex sensors because it's complex logic, and you can pre-program them for how the machine should operate in the manufacturing context. So in other words, there's so many different types of sensors. I mean, here's a chart that actually lists some examples of sensors. You have temperature sensor. We talked about pressure. Could be position sensors. There could be sensors on based on the lat long. Where exactly the position. We can actually track that, and you can sense for a chemical. You can sense for gas. There's so many applications. In fact, it'll be an interesting way to look at the application of what each of these sensors does, and then look at how we can put this together to create useful applications in a manufacturing or industrial context. Let's take one simple example of one of these sensors. It's often called as the RFID. You might have heard this term RFID. This kind of the full form is the radio frequency identification tag. These are simple, microprocessors with an antenna, kind of transponders that can receive and send information in radio frequency. So they are used as just storing information, sometimes just kind of for identification purposes. And there are simple RFIDs, and they also, just like I talked about, how sensors can be very simple sensors to complex. The same applies to RFID. And you would have seen RFID being used, in manufacturing context to track inventory. It's used in groceries, grocery stores. Sometimes you'll see people take inventory, walking through the aisle. They'll have a kind of a reader in their hand. They're going to scan to see how many milk bottles are left on this aisle or something like that. They just capture the information to track real-time inventory information. Now, the RFID, the way it works is there is a tag, there's a static tag, there's this information, there's a reader that actually kind of senses this tag and then reads that information, communicates with that with the tag, and then collects this information. Just we talked about how devices in the IIoT applications collect information and provide real-time information and provide access to decision makers so that they can now derive some actionable insights and make decisions to improve the manufacturing process. So in the case of grocery store, you'll see that as they're scanning these RFID tags walking through the aisles, I mean, people in the back end, they're kind of getting this real-time information. They know exactly which particular product is moving fast or not moving, so that they start getting this real-time transparency in the supply chain movement of this inventory, so that they can replenish it faster. So that's one example of how RFID is used in terms of tracking the location, getting information, and of course also use some analytics to make some decisions.
Sensor team.
Today, we have Annie Zhang, who is the technical specialist in digital twins and artificial intelligence at Ford Motor Company. Annie, welcome to the course.
My pleasure. Thank you.
Thank you very much for taking time from your busy schedule. I would like to open our discussion with a broad understanding from you in terms of how do we explain the concept of industrial Internet of Things, which is called IIoT.
I think maybe the one way to start it would be start with IoT first, Internet of Things, because that's just something that I think every one of us maybe already living in it, but without really calling it out. I think that we all have thermostat at home, and if you want to know your temperature in your living room, in the old days, you would use a thermometer, and it might read, I don't know, 70. That is how we got to it.
Mm-hmm.
But how can we get to the temperature easier or more regularly? I mean, you do not, if you want to know temperature, today we don't know because we want the temperature to be set at a certain time. So therefore, you start looking at a device that's smarter than just a thermometer, but it also has a sensor that can measure the temperature, which is a thermometer. And by making it smart, what you do is literally you connect the reading from that thermometer to something that's smarter, could be an algorithm, could be something else, that can be leveraged to control the temperature of your room. And therefore, you have this device connected. And when we have the capability to connect this information to our internet, now you get that little thing called Internet of Thing. Not things, yeah, but that's the thing. But when you have a number of those, and now that's the term IoT come into birth. And we all know nowadays, we don't have to sit in our room to know what our temperature is. We can be in Cancun to adjust the temperature at home if so desired. And I'm sure you don't want to do that. So if we spin this concept into manufacturing, it's really about the same. We have so many plants globally, and each plant runs its own thing. We might not use thermometers, but if we ever use a thermometer or any sensors that's like that nature, guess what? We will be able to connect them through smart devices to the internet and eventually be accessible from anywhere. So that is I think that probably is the easiest way to get to understand what that IIoT is. It is industrial use of the Internet of Things. It's more target toward manufacturing industry or any other industry type of usage.
Okay. IoT, Internet of Things, everything. Relation, sensor annotation, resolution, I like keep on this. You want the 10 years ago, smartphone, สวัสดีครับ computer, today money, smartphone, everything smart. Okay, for
And building on that, can you so basically the concept of a sensor that you explained using the thermostat, right? Now, how do you categorize these sensors in terms of classifying them, the different dimensions of the complexity of the logic inside, and how do they vary by cost? How do you categorize these sensors?
That's a great question. I mean, if we were talking about these IoT for setting, we probably don't get into how we classify them as much, but we do use them for a purpose. And I think depends on their functions. We would call them differently. For instance, error proofing is one of the most popular thing I think that's used in any plants that use automation. Error proofing use a number of different sensors, and I don't know whether we call them error proofing sensors, but there's a candidate of such, which is error proofing. Okay. And then there's also things like getting to know the actual machine or the asset states, and most of those will be through the PLC, a programmable logic controller. Those is also very, very popular inside any modern plants. So I think between sensor and PLC, I think that probably is how we will try to classify them. But as far as IoT goes, we actually expand the concept of that to any device, that's the thing part, any device that we use that can generate data. We consider all of those part of IoT family, and we harvest on the information on that.
I understand the PLC part where there's a logic for this program. The first one, in the error proofing, right? We talked about how do you kind of describe how does a sensor work?
Okay, let me give you a specific example on the error proofing. Let's take a seat in a vehicle. There's seats, right? There could be leather seats, there could be fabric seats, or different colored seats. But when we put a vehicle together, there's only one seat that should go in there, right? If it's 10 color, it should be 10 color. You cannot put in a gray color seat. And error proofing really means that we do not allow operators to put in the wrong thing by design. So there's no way they can put the wrong thing in. That's error proofing. So what we do is normally when a seat, maybe a number of seats is lined up next to the operator will need to scan something to recognize what that seat is. And behind the scene, there'll be servers and systems that will track, is this the right number for the right seat? If it's yes, of course, it continues. And if it's not, you'll definitely will see a buzz or Z or some sort, and it'll be apparent enough for the operator to know, oops, yeah, that's the wrong one. So that is in a nutshell what an error proofing is.
Version reflects on the sensor that you are encountered in a manufacturing setting. How could you categorize them in terms of function they serve? Function, thermal, optic, impression, something like that. Wave sensor. Okay. Economy of sensor technology.
Now, if you understand the trade-off between cost and complexity of sensors, it's kind of very interesting. I mean, of course, as we would expect, the simple sensors are going to be cheaper, and the more complex the sensors are, as we discussed earlier, they can handle potentially multiple inputs, and they can actually give multiple outputs. And of course, more importantly, the complexity of the logic in the middle, right, that we talked about, that's what's going to be increasing the cost. You'd see that as the complexity goes up, you would find as in the curve, the cost of the sensors also goes up. More interestingly, we have to understand that it is the complex sensors that actually also create opportunity for manufacturing companies to develop some contextual applications that will be very useful for decision makers to improve the manufacturing process, right? So, for example, in the context of RFID tag as a sensor technology, like there could be simple example, what I call is passive RFID, like, where it just kind of, if I'm kind of carrying an RFID badge with me, then all it is doing is it is kind of recognizing me as with that RFID tag, and the sensor reads, then it knows that this particular employee with this employee ID or number, right? And those sensors, the passive RFID sensors, are very cheap. I mean, in fact, the cost economics of sensor technology, as we talk about, these passive RFID just storing the location, so storing the information, they actually just cost only a few cents now. However, there could also be complex RFID sensors, like technology can be implemented with what I call the active RFID, where the RFID tag itself will have a chip and then will have some logic in it. So what it'll do is it'll actually take some actions, take some output actions, depending upon some information that is getting from sensors. For example, right, you could actually put RFID tags in kind of fresh produce that you're actually shipping, say from California, you're actually shipping tomatoes from California into Michigan. Let's assume that. Okay? As they're traveling by road in trucks, I mean, the trucks are supposed to be refrigerated, and of course you certainly want the refrigerator to be on for those tomatoes to be fresh, right? But say, for example, for some reason, the temperature inside the refrigerated truck actually goes up because it's not working or whatever reason, or the truck is actually stopped in some location for a longer time. Then the RFID tag in those within the truck, kind of, in fact, attached to each of the pallets for the tomatoes there, they can sense the movement of the product. They can sense the temperature, and in fact, if it actually crosses a particular limit, they can actually send back information. And those are what I call as active sensors that have some logic in it to kind of raise the flag if something is wrong. So you can see, of course, they are complex sensors. They're going to be kind of a little bit more expensive than your passive sensors, but at the same time, they are now giving more contextual information for manufacturers to take action. So we can kind of, if you're the retailer kind of selling those tomatoes, you can get notification that, oh, the tomato is going to be there late, or well, the temperature is not good and they may be not good quality. You probably have to do some more careful quality inspection with this product coming in. Information like that, which often leads to improvement in the process or reduction in cost, and so many dimensions of benefits you can get from those contextual applications.
Common business cases.
In fact, if you take the same sensor example, sensor technology, and there's so many examples that you can actually relate it back into manufacturing context. It could be used in smart maintenance. So within the manufacturing process, just assume that if you have sensors and machines, and a particular machine, say for example, it's losing its calibration or not working to the precision it is expected to, right? And there are some parameters you put sensors about those. Any deviation in those parameters, the sensor can actually capture and immediately send information back. So what does it do? Even before a machine is breaking down, if there's any deviation, there's any quality issues, the sensor immediately catches that and sends the information back to the decision makers, and hence they can actually kind of what I call as smart maintenance, because you don't wait for the machines to break down, but you actually proactively get information, through the sensors to improve the decision making. Now you can also make the supply chain more predictive, because just imagine if you're using RFID or some similar sensor technology, say with your downstream supplier, then you could actually know as soon as the product gets shipped from the supplier through the sensor technology, you can say, well, this product has been shipped, it's actually on the way, I'm actually going to get it tomorrow by 8 a.m. so that will be right on time for my shift. And if it's not going to happen, you will know that it's going to disrupt your shift. So this predictive supply chain, you can actually predict what's going to happen. That actually helps in improving the overall process operation. Now you can also improve the customer service. Just like the example I gave you about a machine inside the manufacturing process, you can also do in case you think about intelligent products. Now we'll see more and more products that are now software enabled. We have sensors embedded in them, and in fact we'll talk about this more in our next course on digital twins. But the point I want to make here is that if you have sensors in the product that's being used by the customers, you can use the same logic. And in other words, you get information through the sensors on how the customer is using the product. Not only that, you can proactively address any problems that the customer may face. So these are some of the examples that in terms of what you could use with the customer in the context of manufacturing. Sensor technology can also be used in safety. For example, there are regions in manufacturing you want to protect, right? I mean, you can actually kind of put sensors around them to make sure that people don't get in that area. Or so, I mean, you can actually sense for chemicals leaking, or you can sense for some gas leaking. So many applications of sensors that actually can improve the overall safety in a manufacturing context. In summary, what we talked about, we actually addressed, in fact, what is this sensor technology, why this sensor technology is one of the fundamental building blocks of IIoT applications. Then we understood sensors from simple sensors to complex sensors. We talked about RFID as an example of a sensor, how it works, how it can be applied in manufacturing, and we talked about the economics of sensors, right? In terms of what happens, the cost of sensors as the complexity goes up, and then at the same time, it is the business value benefit that also comes with the complex sensors, and hence it's a trade-off decision makers need to make how they design the application, kind of looking at the cost and also the business value benefit they get. We also then finally talked about how some of these technologies, sensor technologies, can be used in the context of a manufacturing operation.
Steve.
Agenda, this discussion has been quite fascinating in terms of the journey of digitalization of Tata Steel. Let me get into a specific technology like Internet of Things, or IIoT as it is called. So can you give us an example of IoT application within Tata Steel? And also, it's been talked about that often these digital technologies have also helped companies manage the global pandemic in a more efficient and effective way as compared to the competitors.
But absolutely, this is the most passionate subject, and this platform I personally take a lot of pride in working on it. So I will talk about it, and there are many other examples also I will give. So just going back a little bit, pre-pandemic, the question was very simple. So our CEO and MD asked the question that right now, how many people are in Tata Steel premises? How many contract workers? How many workers? And who are there? In which operation? Which part of the plant? What are they doing? And are they all safe? Because steel is a hazardous workplace, right? So it's not safe. So
and you employ thousands of people, right? In Tata Steel.
Almost 70,000. So most of them are contract workers, but there are also officers and non-officers. So yeah, there's a demography. But total human who will be there in Tata Steel India is 70,000, and there are more in the other divisions of Tata Steel.
So the request from the CEO or MD is visibility of who's where, is it?
Who's where, and what is the count? Simple question. How many people are now? Not all 70,000 are inside the plant at a given point in time, because they come in shift and whatever, right? So it's a simple question. Just give me and you all have the RFID badges. So people will say, okay, now I have to go and check how many people checked in, and from the attendance register. Then you go and add, and by the time you do the calculation, the shift has completed, and people will go away, and new people will come in, new shift will start. So it is impossible. You cannot do it. So what we did is that the following. It's IoT. You asked the question of IoT. So we thought about, why don't we geofence the entire company? Yeah. Disneyland, if you look at, it is also following a similar method, right, to track the kids and for safety and all that. So we geofence the entire company and put around 40,000 beacons. The beacons are the receiving device. They're just there in different demographic inside the plant. And we use LoRaWAN technology, which is because of the lower frequency, its penetrability through metal barrier is very high. And steel is an industry where we need to focus on the high frequency energy will not work because it will not penetrate through the barriers. So we use the LoRaWAN technology. So we had the technology part done. And then all of us carry some RFID card as our identification card, whether you're an officer, whether you're a non-officer, whether you're a contract worker. So you have an RFID card that you do your attendance and you come in, that's your identification card. So we just pasted another card behind it, which we call Suraksha card. Suraksha in Hindi, we can say it's a safety card, right? So we named the program as a safety program. And then whenever you're coming in, and you're coming in close proximity, 10 meters with the beacon is now sending data to the cloud every 2 seconds, about the coordinate of a person. So from that, and putting the geospatial map on top of it, and we did a zone mapping of the entire organization. We created the organization, we did a zone mapping. We exactly know who is where in which location. Right? That is the first and foremost. So in real time, I know that, okay, so many people, you won, 2 seconds. It's on the real time dashboard. Right now, these many people are here, these many people are at this gate, these many people are in this plant, all that is available. Just live dashboard. Now the second question comes. Now,
so
once you're done, you ask the question.
Yeah, just for the clarification for our student learners. So the geofencing is basically you take a geographical area and then fence it with sensors, small sensors called beacons, right, which actually kind of can track this particular card that you've given to them with just being kind of within that area or not, correct?
Yeah. So you put the beacons are devices which will just it's a passive signal it will get.
It's a receiver.
And it's a 10 meter radius. 10 meter radius is the proximity that it covers. And you put it in whatever way you want to put it. It's not only on the border. You can put it anywhere.
Yeah, and it detects these card holders when they come near that particular beacon. Yeah.
10 meter radius it will detect, and then it goes into the cloud, right?
Okay, thanks for
now. Yeah, and then there's a zone mapping. So I exactly know from the lat long that okay, this is a zone, this is the exact area where the person is. And there is some accuracy issue of plus minus 1 2 meters, which is okay. Now the real interesting part. You asked me about the question of how did you excite the organization. Now this was done by IT.
Yeah.
Then we took it to business. We showed to MD and showed to all the executives of the company in one room that this has been done. Now they said, oh, I can do the safety index. I can actually find out whether he has gone into hazardous location, whether he has gone into an unproductive area. So many new questions came up. So then the power of analytics come because the data is now there. The data has come to the cloud. So now we wrote on the power of analytics and AI to analyze the data to say that you have a permit to do a hazardous job and you are in the hazardous area, so you're fine. But you don't have the permit, but I'm finding you in a dangerous and hazardous work area. So immediately you have to retreat from there. Yeah. Or somebody has fallen. There is an SOS button also we gave on the card. Somebody has just fallen sick and needs help. He or she can press the SOS button. Immediately an emergency response team can go and retrieve the person. Look at the safety index of the company, right? And then there is another application of productivity. Yeah. So if you're just sitting idle in an unproductive zone, suppose there is a restroom and you're sitting in the restroom for 2 hours, let us say either you're sick or you're just being unproductive. And the data will tell that you're not even moving. There's an immobility index, it will even beep. It will alert that the person is not moving for so many hours, right? Or the person is not moving from the zone where he's not supposed to be because that's the restroom, right? You're not supposed to be there for 2 hours. So it will also be, right? So all those new use cases keep on coming. Then what happens? Security. If I'm finding a group of people where they're not supposed to be, the security officer will get an alert. Then we go and find out that why are these guys there? Because they're not supposed to be there. That's not their work area. Yeah. So they come out of their assigned work area and be loitering somewhere, right? So it has a security use case coming out. Yeah. Then COVID happened. So before we go to COVID, so basically what you're saying, Jayanta, is that you put the basic IoT sensor infrastructure in place, then it's almost like imagination is the limit. You started getting productivity application out of that. You started getting a safety application out of that. You started getting a security application, right? These are all like how you kind of manipulate and how you use the logic of the sensors to derive actionable insights. Okay, thank you. Absolutely. Actionable insights because you have the data. So once you have the single version of truth, now you just keep on mining the data and create different use cases.
In your own manufacturing experiment, which kind of STIC K have you encountered for sensor and IoT? Yes. Sensor and IoT we can use SCADA for like control the machine system and safety sensor to protect people when the machine runs. That's it. Having safety.
Yeah. Then COVID happened. And the most important dimension, the fourth dimension, we could find that business say now, very simple application, social crowd. We have to not allow crowd, right? That's the first thing. And in the plant, there are so many people and the workers are all talking together in a 100 square meter radius and there are so many people. Immediately from the same application, we could find out that so many people are close to each other. So there is a crowding that is happening. So social distancing norms are being broken. So we intervened and alert went to the respective supervisor or the plant chief or whoever. And immediately there was a public announcement system where people said that, okay, do not crowd here. Or a manual intervention was done to disperse the crowd. That is one application. Then we thought that why can't we measure the distance between 2 people? There is a beacon, there is a tracker. So we can do some mathematics and analytics and AI. That is where AI came in. We could optically measure the distance between 2 people. And if it is not by 2 meters or 6 feet, we'll again raise an alert on the MI's dashboard that people are not following social distancing norms. And India, it is extremely important, right? Because of the density of population. And we could manage the social distancing by doing digital response across data scale, sitting in one command control room. Because everything is just alerting, right? Then we say that we democratize the data. Why do you have a command control room? Give it on the iPhone and Android phone on every officer. So the respective area, they used to get an alert. Okay, here you have to go and intervene because there is a social distancing norm that has been broken.
Violation. Basically, you made it as compliance tool for
compliance. Yeah. Then canteen when you're eating, you're not maintaining social distance. The same algorithm started working here, right? Then we started recognizing facial mask. That is an imaging algorithm. So you're not wearing a mask, so the system will alert, right? So all these things came up. And then what we did to your question that we started this discussion with, like in Argo Setu is an India government app. So we created a questionnaire for people. Have you been in contact with a COVID patient? Have you been in a crowded place? Are you feeling having fever or some of the symptoms and all that? And that questionnaire will give you a status of either green or amber or red, right? Now, then also we are trying to now then see that is a questionnaire. But once you have come inside the plant, suppose even we have violated a social distance of 2 meters, and we have been working closely together for say a couple of hours, and now I fall sick. I report sick. I have a COVID this thing. Then immediately the system knows Now he's become a COVID patient, but yesterday or week before he was working with Krish, and they were together for a couple of hours or more. So Krish becomes now a highly susceptible candidate. So he has to be quarantined and medical intervention, or he has to be under observation. That is how the footfall management happened. The whole proximity analysis, real-time proximity analysis. That is a new use case that came out.
So basically,
you convert it into contact tracing application. Contact tracing. So become a real-time contact tracing, and at the gate, on your mobile phone, the security guard, you don't need him anymore. What we did on the RFID card, we disable the card if you're red. So I don't need to deploy people to check at the gate. So make them safe. Because if I have a security guard there, then that person will also become unsafe. So this particular person, when they're coming inside the gate, he was barred entry because it was a red risk. Okay, so this green, amber, red status became a real-time thing at the gate, and the panel will not move up because it is automated now. So we passed on the flag and made the flag red. So it will not move up, so the guy has to go back, right? And the manager will know that now you have to intervene. So that is how this whole thing works, right? So and it is still going on. We are finding so many applications of this connected people. Continuously, we are finding use cases and applications, right? Because once you have the data, you can just put on the imagination, as you said. The sky is the limit. Right? So that is how it works. Yeah.
Thank you.
So our COVID response has been completely digital, and then when government would come and inspect, so they also then we can show this is how we are managing. This is the data, and then they put all the data there. So it becomes audit friendly and all that stuff.
Done when they are password. Nine question. Who's that my back? Oh. Who's that my back before they in the show Internet of Things? Okay, I lost. Maybe we do it later. So